Hi, and welcome to episode 13 of Johnny Does .NET. My name is Johnny Hooijbergs, and in this series of videos, I'd like to tell you a little bit more about my favorite programming platform, .NET. And in this final video of the first season of Johnny Does .NET, I will recap everything that I told you in the past 12 episodes. And I will do this based on 3 of my personal projects that I built throughout the years with .NET technology. When working with .NET, so every now and then I'd like to do some personal projects. Personal projects because I like to do them, but also to learn new pieces of the technology, of the .NET technology myself. And also to navigate the whole landscape that .NET actually is, and to, again, learn these new technologies and how to use them in specific situations that I haven't used them before. So I have prepared Visual Studio, and I've prepared Visual Studio with 3 of my most recent personal projects that I really had fun making. The first one I want to talk about is CloudSnake. CloudSnake is a solution that I created and prepared to teach my friends and my colleagues to work with new pieces of the .NET platform that they weren't familiar with yet, but also to teach myself and just to basically have some fun. So if I look at the solution for this CloudSnake project that I created, you can see that it contains multiple projects. And I told you in the previous episodes of JohnnyDoes.net that each of these projects is based on some kind of template to create a piece of software or an application. Now, all the way in the bottom is like the main application, the main project for this solution, which is a Winforms Windows user interface application. The reason I chose Winforms is because I have some history in Winforms, and I really like to use Winforms when I very quickly want to do some proof of concept with a user interface that is somewhat graphical in nature. So CloudSnake is, of course, a game to play Snake, but in this specific case, it's a game to play Snake in multiplayer. So with multiple people at the same time, whilst in the same arena, basically. So that's why I created a Winforms application. And maybe instead of talking about it, I will just show you. So if I run this Winforms application, and I have some patience again, it will show me a window with my very good graphical skills. I've created this purple looking window with the main menu where you can start a new game. So you can play a new game of CloudSnake, or you can join an existing multiplayer game. So you can play this game with friends or colleagues. And if you are the first one to open this window, you can go ahead and start a new game. You of course, provide the name for you as a player, your real name or your nickname, and you create the game. Now, this application will now communicate with some kind of backend server to create a new game and to add me as a player to that new game. Also, that new game has received a unique identifier, a unique code that you can easily share with your friends. So those friends can then join the same game and you can all play together within that same game arena. So basically when you have a friend or a colleague and he or she also starts an instance of this Winforms user interface project, they of course get the same kind of user interface, and instead of starting a new game, they can join an already existing game. And when they join a game, they just have to play. They just have to submit their name. In this case, it's not a fiend, but a friend of mine, and he can also use that same unique identifier game code to join the same game. So this game code is M4LYYQ. And if I didn't make any mistakes and I press join game, we will now be both in the same game lobby. So before starting the actual Snake game, we are now waiting in a game lobby until both of us are ready to start playing. So both of us need to click the I'm ready button. And whenever both of us is ready, the game will automatically start. So if I do I'm ready for my friend, then you also see that these two instances of the Winforms user interface application both at the same time acknowledge the fact that friend is ready to start playing. And then when I'm ready, so when Johnny is ready, clicking the button, the game will automatically start. So go, and then you'll see that both screens are actually doing the same thing at the same time. So you can see that we are now playing at the same time. Of course, I am controlling my own window. I can't control the two windows at the same time. But this is basically the idea. Maybe you noticed, but the two snakes intersected, but they didn't really had any issues with that. That's basically because this game is a proof of concept. I did not finish it, so there's no collision detection for these snakes. It's just the proof of concept that I wanted to create to do this multiplayer synchronized gameplay with multiple players, and how to do this in .NET, or a possible way of doing this in .NET. So I am now playing the game. I have a hard time stopping to play because it's so fun, but I'm going to stop and I'm going to show you a little bit more within Visual Studio. Also, when one of the players closes, the snake will disappear for all the other players, because basically that player has abandoned the game, so he's not playing anymore. And the idea would be that the last player remaining will be the winner in this multiplayer game. So as I already told you, we've got a Winforms front-end application containing that user interface, but now we still have to somehow communicate with a backend server to do all the synchronization between all the front-end clients and stuff like that. So I actually created two additional web service applications. One of these is a web API, an ASP.NET web API. So it's a web service application that you can use to send and receive data from. So send data to and receive data from. This web API will basically do all of these small tasks like creating a new game, joining an already existing game, telling the game that you are ready to play, and abandoning a game. So when I open this web API, and you see that there's very few classes inside of here. There's only the API helper and the program. So if I go to the program, top level program class for this web API, you can also see that I'm using the minimal API. The reason I'm not using controllers and the full-blown API style is because I only have limited amount of endpoints for this web API. So there's only 6 in this case. So I think the minimal API is a nice way of creating a very small, very compact piece of code to allow you to do a couple of endpoints without creating too much confusion. So in this case, there is a very simple endpoint called status, which you can just check. If you do a get on the status endpoint, the web service will return everything is fine, and so you know that the service is actually running and it's healthy. The second one is post to the endpoint games. So a post is basically sending data from the client to the server, so making a change into the data that lives on the server. So what are we wanting to change? We want to create a new game. So we are posting to the game's endpoint to create a new game. And this create game request object will then contain your name as a player. So this endpoint will basically create that new game, make you as a player join that new game, and then return the generated game code back to the requester, back to the client basically. Then we have 3 very similar endpoints. We have again post endpoint, so we are sending data from the client to the server, where we can send the fact that we are willing to join a specific game based on a dynamic game code. So when you type in a game code and your player name and telling the server you want to join, you have to fill in all of that data inside of this little join game request object, and you push that to the endpoint games / then the game code, and then the word join. Now, very similar to remaining posts, one if you are ready, so for a specific game code and a specific player name, telling that you are ready to play. And the other one telling that you are abandoning an already active game so that your resources can be cleaned up and you are basically removed from that active game. And then finally, there's a very simple get endpoint to get all of the current active games. So very easy, just getting all of the active games will give you a list of all the running games. So this is the API. So this is a very simple web service where a client can just ask a question, the web service will do something, and it will return an answer if necessary. Also, all of the other projects in the top, they are class libraries. So they are projects that I've created to be able to reuse the functionality that lives within them. So for example, I have a business project, and that business project has a game manager, and this game manager is a class that actually contains all of the logic, the logic to manage everything that's going on. So we can again create a game, we can join an already existing game, we can tell the game that this player is ready, and we can get that list of active games, and we can get these are helper methods, and we have an abandoned game method. So all of the logic is here in this game manager, in this class library project, and now this project can be reused within the API. So in the API, minimal API, I'm basically telling for each endpoint using a helper class that I've created that, okay, this is my API HTTP endpoint, and this endpoint uses the game manager to actually perform all of the necessary actions. Now, whenever you get a request, you have to do arrow points right. So you have to do on the helper post, which means post an HTTP message, and you have to call on that game manager logic class, you have to post the method or call the method create game with that request. So we are basically just pointing that endpoint towards my game manager. So we're not doing all of the logic here, we're just pointing it towards the game manager, and then the game manager will actually do all of the actions. And the reason I put the game manager into a separate class library is because I have a second web service. There's also the SignalR web service, and this is actually a special one. It's a separate piece of the application. It's a separate process, a separate web application that actually combines SignalR, which is an ASP.NET real-time communication technology, which I haven't yet discussed in my previous videos. But I'm combining that with a worker service. And you already know what a worker service is if you looked at my previous videos. So a worker service is a long-running background operation that continuously runs and continuously does certain stuff. So this is a combination of that web application with the SignalR real-time communication technology and a worker service. Why? Well, because when multiple clients are started at the same time and they are playing the same game at the same time, they all need to be synchronized. So I need a long-running service that can do all of this synchronization for me. So the real-time communication part from SignalR is because not only should a client be able to ask a question to a server and a server can respond on that, but the server should also be able to send data to all of its clients. And that is why it's real-time communication. So the server, whenever he wants, can send data to all of the clients to make sure that all of the clients are synchronized. So when the server sends it to all of the clients at the same time, all of the clients will receive that information about at the same time, and they will be synchronized in that way. And then the worker part, the background worker part will be to do this like every half a second, for example. Every half a second, every 500 milliseconds, the worker will tell SignalR to send that synchronization data to all of its clients, and this will make the snake move every half a second for all of the clients at the same time. So if we look at the application configuration, so the top level program for the ASP.NET web application and the worker service, you can see that we are indeed adding that hosted service, so that background service for something that is called ticker worker. And if I take a look at this ticker worker, you can see that when executing it, it will run in an infinite while loop until we stop the actual service. So again, you can install this as a Windows service or as a Linux daemon, or you can put it in a container and run it somewhere in the cloud. I will discuss much more about those things in later seasons and later videos. But for now, we are just looping like an infinite loop until this process is stopped. And at the end of this logic, we are actually sleeping for 500 milliseconds or half a second, which is not entirely correct because all of the logic that lives on top of this actually also takes some time to process. So we are actually using a stopwatch to measure the amount of milliseconds it takes to run all of that code. And then we are doing some math where we subtract the amount of milliseconds it took to run all the logic from that 500 milliseconds, so that the remaining time is always 500 milliseconds in total. So that every 500 milliseconds my game is synchronized and does everything at the same time. What basically happens in between is getting a list of all the active games, and then within all of the active games, for reaching all of the players, so looping through all of the players and actually doing the things that the players have done. So if a player changes direction, we need to change the direction of its snake. We need to calculate the next piece of the snake, and we need to subtract the last piece of the snake so that the snake is moving forward. We need to check the collision between snakes and food so that the snake that actually eats the food will grow a little bit longer, the food disappears and new food gets generated. So all of that logic lives right here. And as you can see, we are also using that same game manager. So it's the same game manager containing the same method as we are using in that API. But because that logic is in a separate class library, we can just reuse that from one project to the other project. So you can have a reference from one project to the other project. So that project uses the other project and now has access to all of the things that is inside of this project. So the game manager again is reused between those two projects. Of course, in the end, just before we are actually delaying for 500 milliseconds, we are telling the ticker hub. So a hub is a concept from Signal R. It's that real-time communication thing. So that hub will actually be able to send data to all of its clients or receive data from all of its clients. So if you look at the hub, this hub is again specific to Microsoft ASP.NET Signal R. And this one has that method called send game state. So I can send data to all of my clients or to a group of my clients. And in my case, because we can have multiple games at the same time with multiple players, all of these games are basically a group of clients. So the example I showed you before were two clients that shared one single game. So those two clients were in the same group. And I can send them data, but only that group, because I'm going to send that data for each game individually. I'm not going to send the data to all of the players because the data will be different from game to game. So again, clients.group with a specific game code will be that group that shares the same game, and they will get sent an actual game state object. And that game state object contains all of the necessary information about where the snakes are located, how large the game is. I mean the grid of the game is, where the food is located, stuff like that is all inside of this game state. So if I go back to the Winforms application, it has one form, so one window, and this window uses that Signal R server, so it will connect to that server. We set up a connection, and then we listen to that event called received game state. So whenever a server calls the received game state on the client, this expression will basically be triggered automatically, and I can react on that. So I can change the game state. I can remove all the players and add all the players once more if I'm updating that list in the lobby, and I can tell when the game is ready or not ready, that I need to change to start playing the game or actually stay in the lobby. If we continue, for example, this event, when you close your main form, so when your window is closed, I actually need to abandon the game. So when I am playing an active game and I close my window, I need to call the API to abandon the game, and then the API will make sure that that player is removed from that active game. The active game, of course, uses the game code, which is located in that label, and it uses the player name, which is located in that text box. So I'm just submitting the game code and the player name. So now my game manager in the backend actually knows to abandon that specific game. So these are the two different communication services here. So the game client.abandon calls the API because it just wants to make sure that the API does the actual thing. But then here with the signal R, we are using the other service that is using signal R to do that real-time communication and synchronization based on this, this event right here. If you go a little bit further, you can also see that there's a paint method. That is actually the reason why I like to use Winforms when doing these kinds of graphical applications, because in Winforms you can very easily paint pixel by pixel on a window. So I'm actually painting this game in 3 different steps. I'm painting or drawing the entire world, which is the grid. Then I'm rendering or drawing all of the snakes. So I'm putting all of the snakes on top of that grid. And then finally, I'm rendering all of the food. So in this case, there's only one food, but I'm rendering it at the correct location, which is then that yellow circle. The snakes are the colored rectangles that form a snake. And then the world is just the black and white grid in the background. Whenever we are not inside of an active game, so when we're inside of the lobby or the main window, I just need to clear the entire screen so that all graphical pixelated drawings are removed so that the graphics are clear. Then of course we got something like key down, where when the actual state of the signal R connection to the backend is connected, so when we are synchronized and we are actually listening to the server, and the current game state is playing the actual game, I can use my keyboard, and when I, for example, press the WASD keys or the arrow keys, I can change my direction from north to east, from east to south, from south to west, or from west to north, or the other way around. And also, of course, when going south, I can't go north because you can't backtrack into your own. You always need to make a turn 90 degrees to the left or to the right. And that's basically it. This is my complete Cloud Snake application that contains multiple pieces that all work together. And the reason it's called Cloud Snake is because, again, this was an exercise for some of my colleagues and some of my students, and they needed to learn how to work with .NET and cloud deployments. So all of these applications can be deployed separately to a cloud environment and then work together within that cloud environment. That's the reason why there's also 2 Azure Function apps, but I will discuss Azure Cloud and Azure Function apps much later in this video series. So with that, maybe we can move to one of my next projects, which will be the My Sauna project. So the My Sauna project is a personal project I did a couple of years ago when we had our own sauna installed at home. So my wife and I decided we really like to go to the sauna. So we decided to install a sauna at our house, and it's actually in the garden. Now, a sauna is a very simple thing. It needs to heat, and you can turn on the heat or turn off the heat based on some goal temperature. So there's a couple of electronics inside of the sauna, and there's also a little display that shows what the actual temperature goal is and what the current temperature is and how long the session needs to be active. But as a technology kind of guy, I didn't really like the user interface. It was very simple, very old school, and there was also no way to send the sauna commands from a remote location. And because the sauna is located in the garden and I live inside of my house, I always needed to step outside to actually make sure that the sauna was on, was already at the correct temperature, stuff like that. And I'm a lazy guy. I'm a lazy developer, so I really want to use my smartphone for stuff like that. So I decided to basically rewrite the software for the sauna myself using the technologies that .NET offers me. So first of all, I decided to create a mobile application that runs on Android because I have an Android smartphone, but I also wanted to have a very large Android tablet inside of the sauna to show me in a very modern way what the current temperature is, what song is playing, for example, within that Bluetooth connection in the sauna, but also how long the current sauna session was still active, instead of the old display, which was actually too small to read from a distance. So for that, I used MAUI, the multi-platform application user interface technology. But because I did it a couple of years ago and MAUI was still quite new, I used Xamarin. And Xamarin is actually the predecessor of MAUI, where you could create mobile applications for Android and iOS. Now, Xamarin is an older technology, again, that does the same thing as MAUI, but only for Android and iOS. And last year, MAUI became the new thing, which will basically be the next Xamarin. So Xamarin will cease to exist in the future, and we will only do MAUI. And actually, you can see here in that solution that I had my sauna.frontend.phone.android, which is the Xamarin project. And then I also built the new MAUI project to do basically the same thing, but then in MAUI, which is a more modern technology. Now, the cool thing about MAUI is that we are not only creating Android and iOS applications, but those same applications with only one code base can also run on Windows, on Mac PCs, and in the future there will be more platforms added. So again, Xamarin was only Android and iOS, where MAUI has support for multiple more of these platforms, which I think is very cool. So before going into the code a little bit deeper, let me show you the result. A Xamarin or a MAUI application can be tested from an Android emulator, for example. So I'm doing that right now. So this is my Android emulator starting my Sauna application. And as you can see, it's a very simple application. It just has a couple of pieces of text that show me all of the information that I need. It shows me that the outside temperature is 17 degrees Celsius. It shows me that today is Sunday, the 26th of June, and that it's 10:50 a.m. The current sauna session is not active, so it's sleeping, so the sauna is not doing anything. And the current temperature within the sauna is 19 degrees. It should be around the same as the outside temperature, but the sun is shining, so the sauna is getting a little bit hot because the sun is shining onto its windows. And then on the top right, there's the current power usage that the sauna is actually using. Now in the bottom, there's two buttons. One button to start heating the sauna using the heating, and the other button to start the sauna session using the infrared panels. So there's two options here. You can choose if you want to have the relaxing infrared sauna, which is not as hot, but you have that heat from the infrared panels, and you can start the actual heating sauna session, which can go to 100 or 110 degrees Celsius. So if I want to start a session, for example, I just click one of these buttons, it will start the session, the sauna will turn on the heating, and it will start the active session while counting down the remaining time for your session. You don't have to wait until the session is completely over. If you're sick and tired of your session, you can just cancel by clicking the power button in the bottom, and then the sauna session is inactive again. So this is a nice looking, I think it's a nice looking mobile application, which I can use on my phone from inside of the house, but which also displays a very nice interface within the sauna using a large 10-inch Android tablet, which makes it very clear to read. So you always know what the current temperature is and stuff like that. Again, this kind of application is an application that works with multiple components, that works with multiple projects, based on multiple templates from .NET and Visual Studio. So I already talked about the front end in Xamarin or in MAUI, which is the same. It looks the same. I've just built it I've just migrated from Xamarin to MAUI. So we already discussed those, but of course we also need something that listens to these front ends, because I'm not telling my sauna directly from the mobile phone what to do. No, there's something in between there. And the first thing that lives in between is the API. So again, the API, an ASP.NET Web Service, HTTP API, will listen to some of the commands that I can send from the mobile application. And this doesn't use the minimal API, it uses the separate controllers, because I have more endpoints with this application, and I thought it was more structured when putting them in separate controllers. It was easier to comprehend for me as a developer. And you can see that indeed we have some categories based on these controllers. For example, I have my sensors controller, and these controllers, this sensor controller contains all of the endpoints related to sensors. And what can I censor? I can censor the current power usage, which then uses the sensor logic or the sensor manager to actually get to that data. I can get the sauna power usage. Actually, the power usage is the power usage for my entire home. And then the sauna power usage is only the power usage for the sauna. We have the sauna temperature. So what is the temperature inside of the sauna? We have the outside temperature. What is the temperature outside? This comes from an actual electronic device, a temperature sensor. And the outside temperature comes from a web service, so an external web service that can tell me the outside temperature in the city where I live in Belgium. So it's not exactly correct at this point in time. It just gets it from an online service, and most of the time it almost matches the actual temperature, so it's good enough for me. And then we have the get sauna state, which will tell me if the sauna is on or off, or if the infrared is on or off. Another controller, for example, is the session controller. Now the session controller controls sessions, sauna sessions. I can get the current active session. So if a session is active right now, it will return that session. If a current session is not active, it will return nothing. With this endpoint, the mobile application knows if it needs to turn blue if no session is active and sleepy, or red if a current session is active and it needs to show information about that session. Then we have get past sessions. This is basically to get the history of the sessions you already did in the past. We have get session for a very specific ID. So we can get a historic session or the current session based on its ID. We can create a new session with all of the information for that session provided with that. So the create session request is actually an object that contains information about the session you want to create. Because I can create a session right now. I can create a sauna session using the heating, or I can create a sauna session using the infrared, or both at the same time. I can create a session that needs to take 1 hour or 2 hours or 3 hours, and I need to set a goal temperature like 90 degrees Celsius or 100 degrees Celsius as a temperature goal. Now I also have a separate endpoint called quick start session, and quick start session actually uses default values for all of those things that I have talked about. So this is today actually what the application, the mobile application, is using. So you have those two buttons in the bottom, so starting a regular session and starting an infrared session. They will start a quick start session, and a quick start session has a specific goal temperature. For infrared it's 50 degrees Celsius, for the regular sauna it's 100 degrees Celsius, and the duration of the session will always be 1 hour when you do the quick start session. So I don't need to provide all of that information manually. Just with the press of the button, I can quick start that session. And of course, I can cancel an already active session based on the idea for that session. Then we have another controller called samples controller, for example. So basically the sauna, whenever it's active, whenever it's heating or not heating while a current session is active, it will send samples to the server. Why? Because I want to do some history calculations. I want to know, depending on the outside temperature, how long it takes to heat my sauna from, let's say, 0 degrees Celsius to 100 degrees Celsius. And by sending these samples like every minute or so, or I think it's every minute, I can actually build a graph on how fast is the sauna heating, and I can learn from that with a look into the future. So again, when I'm turning on the sauna actually should know from its historic data how long it should take to reach target temperature. And this comes in handy when planning sessions beforehand. Because on the session controller, when creating a quick start session, the session will always start immediately. But when creating a session, you can also specify a start date for that session. And when we have historic data and I tell my sauna to heat up to 100 degrees at 6 o'clock this evening, my sauna could actually know that it needs to start heating beforehand, so that at 6 o'clock it has reached target temperature. So I don't have to wait for it to reach target temperature from 6 onwards. So this is why that historic sample data is actually stored inside of a database, and we can learn from that. So this was the API. Again, the API necessary to do communication between the mobile application on Android to the API, and all of the data will be stored inside of a database. Again, the reason the database is there is for the historic data, but also if I want to plan sessions for later. If I want to plan sessions for right now, I shouldn't really store that information. I can just store it in memory. But if I want to start a session later this evening, I of course need to store that data somewhere, so it's inside of a database. Now, of course, with this mobile application and with the API, I still don't have everything necessary to actually make it work, because I still need an application that sends commands to the actual sauna. And this sauna is using electronics. It is using electronic switches. It is using a temperature sensor. So I need something that is able to read those values and also change the actual switches, or toggle the actual switches. So I've decided to create a processor application, and this processor application is again a worker service. So a background service that is continuously running and continuously looking at the current sauna sessions, if there are any, and if there is an active session, it will do everything necessary to talk to the electronics from the sauna. So electronics from the sauna, yes, .NET has actually a library available that you can use from Microsoft to talk to these very small computers. And today we have these very small boards that contain everything necessary to be a full-blown computer. And we can put an operating system on that, and we can connect electronic devices on that using general purpose input-output ports. And one of the devices that I like to use is a Raspberry Pi. So a Raspberry Pi, again, is a very small computer. It's a very small board containing all of the components necessary. And I have put a Linux operating system on top of that, which is Raspbian, which is basically a Raspberry Pi specific operating system, which is a Linux distribution. So I've put that on there, and now I'm creating .NET applications, in this case a worker service application that I can install on top of that. And because it's a worker service, as I told you before, you can install that worker service as a Linux daemon. So because it runs as a Linux daemon on this Raspbian, on this Raspberry Pi, whenever I pull it from the plug and I put it back in, I don't need to make any manual changes. The Linux will boot up, and automatically all of its running daemons will start, and they will start doing whatever they need to do. And in my case, it needs to start looking for active sessions and talk to the electronics. So if I look again at this worker service, you can see that we are using 3 hosted services. So 3 background services running simultaneously. So your worker service, it can do something in the background, but it can actually do multiple things at the same time in the background. So in my case, I have a configuration worker, which actually means that when I change configuration values in the database from my mobile application, that this configuration worker will automatically synchronize with those new values. So I don't need to restart the worker service in order to get the new values for configuration. No, every now and then, this worker will get the last configuration values from the server, and it will update its own configuration so that it's always correct with the latest versions. Then we have the session worker, which will basically be a worker that looks at active sessions, and whenever a session is active, it will do all things necessary. And then we have a sample worker, and a sample worker will be a worker specific to sending samples to the server. So it will read the temperature, it will read the outside temperature, it will read the date and the time, and it will send that data to the server every 10 seconds every minute when a current session is active, basically. So if you look at inside of these workers, we already We already saw what a worker looks like. We always have that execute async method with then that while loop where we basically just update the configuration and then sleep for 10 minutes. So it will update the configuration every 10 minutes. We have that session worker that will basically initialize that general purpose input output service. So the general purpose input output service will actually make sure that we can communicate with those input output ports so that we can actually read from electronic devices and switch electronic devices based on kind of values. And then we delay for 10 seconds, and if there is a active session at the moment, we will update the active session within that worker so that worker knows what it needs to do. And if there's no active session, I'm going to kill the current session that the worker is working on. And then of course we have that sample worker that will do whenever a current session is active within that session service. I will get the ID for that session, and then I will send a sample request to the sample service, the sample server, the backend server that is listening to this. So as you can see, it will actually ask the general input-output service if the sauna is on, if the infrared is on, it will read the temperature, it will get a timestamp for the current date and time, and it will send that sample request to the backend. Very cool. Now, if we go look into that Gpio service, this actually uses the Gpio controller, which is a class from the .NET package that we use to talk to these general purpose input-output ports. We open all of the pins, the little metal pins that are necessary, because those metal pins have wires connected to them that will communicate with my sauna. So I'm opening them and I'm writing specific values to them. And then when you turn the sauna on, you basically write a specific value to that correct pin. And you can do it for all of these things, but you can also read the temperature from a very specific location on the Linux file system, because this is where the temperature sensor will write its values to. And that is basically the idea. That's it. This is what my sauna application does. Again, working with multiple projects, multiple applications, multiple standalone applications, basically, that all work together. An application that runs on my mobile devices, on my Android devices, an application that runs on a server that is in the garage in my home, which runs the API in the database. And then there's the processor, which runs on a Raspberry Pi, which is very close to the sauna and has some of its pins connected to wires, connected to the actual electronics from the sauna to do all of the things necessary. So again, multiple applications all working together to make one big distributed application that actually does something very, very cool. Now, let's go to the final personal project, which is C# Wars. So C# Wars is one of the most fun projects that I did these past few years. It's basically a project to teach people to write C# code. So no .NET really, but really specific C# code. I decided that it's a very boring job to teach people C# or programming in general, because when you need to start simple, you also have simple and stupid looking applications. You can't create very cool applications that have a significant impact on what people think of it, because it gets too complicated quite quickly. So I wanted to do very simple things in C#, but I wanted the impact to be big. So whenever you do something, when you write a few lines of code, I really wanted the people learning to actually see cool results based on that. So I decided to create a game, and that game is called C# Wars. To create this game, I used the Unity game engine, and the Unity game engine is actually based on the Mono project, which is based on .NET and C#. So you can create games using your C# and .NET knowledge inside of the Unity game engine, which is very cool. The reason I did this project is, of course, for my students, to make them have a very cool game that they can play by writing C# code, but I also did it for myself because I can learn a little bit of Unity, the game engine, and I can do cool stuff in .NET because I like to do that. Now, what you see here is a 3-dimensional arena, or at least it's a 3-dimensional view on a 2-dimensional arena, where a camera is slowly rotating around the arena. So whatever is going on top of that arena will be visible to us as a viewer in 360 degrees right here. Now this arena is a little bit like a chessboard. It has a width and a height, so it has about 10 to 10 squares, and we can deploy a robot on top of this arena by writing a piece of C# code, and then that robot can do things on that arena, again, depending on what we write in C#. So if I go to this web interface, this is the web interface that I built to be able to join a game and to actually write C# code and deploy that C# code as a robot. So the first thing I need to do is log in with my username and password. If the username and password does not exist, the account will be created automatically. And then you have some kind of welcome space. That welcome space will give you information about the game. It will give you a little example of C# code that you can write to actually make your robot do something. So we have a variable called step, and we are loading that step from the robot's memory because the robot can remember things between all of its turns, because a robot will take a turn every 2 seconds. It will do something, and it can store data between those turns. Now, if the value for that step variable is divisible or dividable by 3, which means if you divide it by 3 and you have a remainder of 0, then the robot will turn left, which means it will turn 90 degrees to the left. Now, in all other cases, it will walk forward, so it will go 1 tile forward. Now, because this value looks at a divisible by 3, means that the robot will always take 2 steps forward and then it will turn left. 2 steps forward, turn left. 2 steps forward, turn left. So basically the robot will just be walking around in circles, or squares in this case. And then we just increase the step and we store the step back into the robot's memory. So the next step, it will load that value from memory and it will do the same thing over and over and over again. Now in this game, you can write your own C# code or you can play from a template. Just to give you an example, I will do it from the template. So this is me. So this is my robot that says me. That's the name of the robot. Then I need to divide 200 points between health and stamina. Health being your current health, and whenever you get hit or smacked in the face or whatever by an enemy robot, your health will drop. And when your health reaches 0, your robot will basically be exterminated. It will be removed from the arena and you have died. Your stamina is a value that actually goes lower when you stepping forward and doing moves. So when you are doing movement with your robot, your stamina will drain, and when you're out of stamina, your robot will be exhausted and it will remain locked in the same position, the same place. It can still fight, but it can't move around anymore. And then we can use pre-made scripts. So if I, for example, take the random panic script, this C# script will just do random stuff. So it will get that step from memory. It will check if that step is divisible by 3. If it's not, it's going to walk forward, just like the previous example. But if it's divisible by 3, it will not turn to the left, but it will do something random based on a number between 0 and 4. So 0, 1, 2, 3. If that number is 0, it turns left. If that number is 1, it turns right. If that number is 2, it turns around 180 degrees. And if that number is 3, it will look around and it will look for enemy robots within its vision. So he can only see forward, he can't see behind his back. And it will do a ranged attack on the actual location for that enemy. In this case, the first enemy it sees, because a robot can only do one thing each turn. All the other actions will be ignored. So it will do a range attack on that enemy that it sees. So if we actually deploy this to the arena, and it's been successfully deployed, we can now see that that robot is deployed on top of the arena. It's walking forward, and now it's going to take that random turn around. In this case, it walks forward again. Again, it does something. In this case, it will do nothing. It actually did a ranged attack to an enemy, but there is no enemy in its vision, so it will do nothing. And it will do this an infinite amount of times. Now, of course, you can see its stamina bar is dropping because it's losing stamina while walking around. It's getting tired. So very quickly, I'm going to go back to my user interface. I'm going to log out, use a new player, which is Paul. And Paul will deploy a robot called Killer. And he will, for example, do teleport and hunt. So a robot can also teleport to the location of another robot to be very close immediately, but it can only, it will use a lot of stamina for doing that. And so in this case, it will actually look at enemy robots. When an enemy robot is in its face, in my face means it's in front of me, it will do a melee attack. If there's no robots around him or in his face, he will actually look for robots that are a distance away. It will calculate that distance and it will look at the closest robot to him. It will basically remember the target robot that is closer to the other robots. And then if that robot is not found, it will just turn right and look in another direction. And in all other cases, when the distance is smaller than 2, so if it's very close together, it will walk over there. It won't teleport when it's too close. But if it's too far away, you will actually teleport to the to just in front of the other robot. So if the robot has a specific orientation, it looks in a specific direction, my robot will actually teleport exactly in front of it so that it can start hitting it in the face. So if you deploy this to the arena and look at the actual arena, you will now see that my killer robot will probably look at this one. It will teleport right in front of him, and then it will start hitting it in the face. And you can see that my robot, the Johnny robot, is now losing health because the other one is hitting him in the side in this case. The other robot, for some reason, is still standing there. Now it's reacting. It has turned left, but I guess it's going to be too late and it will be killed by my killer robot, hence the name Killer. So the robot has died, falls to the ground, and it will now get cleaned up from the arena, so it will disappear in a couple of seconds. And Paul, with the killer robot, has won this game. Again, this is the idea of just making my students and people who like it to write C# code, learn to write C# code, have a very small piece of code, and immediately see the result in a fun way in this game when playing C# Wars. Now, what does the actual project and solution look like? It's a little bit more complicated because there's more components to it. Again, of course, we have that user interface, which is in Unity. So this is not part of this solution because the Unity game engine has its own project structure, but it also uses C# code, and it's also available in my GitHub repository. So I will show you my GitHub repository in the description of this video, and you can check out that code. So I have, of course, also a web API. Again, I need some kind of web service that is able to get questions and send data in as a response. So my Unity frontend, my Unity game, actually will call my web API every 2 seconds to ask for the current state. And based on this current state, it will do all of its drawing, it will put all of the robots in the correct location, and so on. So if you look at this, which is also a minimal API, you can see that it has a couple of endpoints like get the current arena. So it will return the size of the arena. Get all of the active robots, all of the robots that are currently active. It has the post endpoints to create a new robot. It has a get endpoint to get all of the players, get all of the messages, delete bots, and delete players, and so on. This is the API. So again, the API is just an in-between thing that will listen for requests from the user interface, and it will store that data inside of a database so that we can reuse that data from other services. Second, we have the web API, the web application. The web application is that application that I've shown you. It's that application that you use to log into as a player and to create new robots. So it has controllers, it has views, and it has models. So it's using ASP.NET MVC. In those controllers, we have a home controller for my home window, my index page, which is the login window, and my play page, which contains all of the information before playing the actual game. And it has my play controller, which contains the pages for templates so that I can select a template, but it also contains the page for custom, because I can do custom games where I write my own C# code. And for these controllers, you also have those views. You have that home that has that index and play view, and you have the play controller or play views that contain the custom and templated views. So again, using ASP.NET MVC to create a user interface that my players or students can use to actually play their game. Now, one difficult thing about this game is that when I play this with students who don't really have a lot of experience, they of course make mistakes. You learn from your mistakes. And it's fun to learn from your mistakes when your robot is doing stupid things. And then you think, oh, I made a stupid mistake, which is again normal as somebody without experience. So you learn from that, which is a very fun way of doing this. But sometimes we make mistakes that are a little bit more bad, a little bit worse than just a regular mistake. And basically, when you make mistakes like this in your code, it can actually kill my application. It can kill my services. When you do, for example, an infinite loop within your code, it's very hard for me to detect the infinite loop, and it will basically be a burden on my service. So my service will run your code. It will be inside of an infinite loop, and I'm not able to get out of the loop, making my service unstable. So because of that, I created a validator application. So it's a separate application, which is a separate web application. In this case, it's using the gRPC web service. And that gRPC web service defines a remote procedure called validate that gets a request and returns a response. And the request is the actual C# script that I am actually going to test for you as a player. So this validator service is its standalone service that will try to compile your code, and then it will run your code. And I will return to you how long it took to compile your code and how long it took to run your code. If your code contains an infinite loop or it's just too difficult and it takes a very long time to run, I will tell you, this is not good, you need to make it better. And for example, there are thresholds when the compilation takes more than an amount of milliseconds, and when the runtime takes more than, I think, 100 milliseconds, I will not allow your code to be added to the actual game. And I will return this to you based on a list of validation messages. I will tell you it takes too long, or if you make actual typing mistakes inside of your code, I will tell you from this location until this location in your code, so these characters are wrong, you need to fix that issue. Now, why did I create this into a separate project, in a separate process? Well, basically, if you are writing bad code and you are making my service unstable, it doesn't really matter because this service can be scaled horizontally. So I can install 10 of these validators next to each other, and I can put a load balancer on top of that. So whenever a request comes in, that request will be sent to a random validator. That validator will do the validation and it returns an answer to your question. Is it validated, yes or no? Now, if you write unstable code and make one of my services unstable, I can decide to kill that service, the entire service, and spin up a new instance of that service. And how can I kill it? Well, in some cloud technologies, you can actually specify if my application or service is using more than an amount of memory or an amount of CPU usage, please kill it for me, and then it will kill it for me. So I basically decided, okay, if my process uses more than, let's say, 64 megabytes of memory, and it uses more than 50% of the CPU, just kill it and create a new one. And if I horizontally scale multiple of these instances with a load balancer on top, it doesn't matter that one of these validators is killed, because there's still other validators available for my players. So my players will never know that one of my services becomes unstable, because it will automatically be rebooted into a new version and all of their new requests will be sent to the other still stable validators. So this is a very cool technology that you can use to actually make sure that your users don't know that your application can sometimes be unstable, crash, and you need a new instance. So that's why the validator is a separate process, so that I can deploy it separately to a cloud environment. So to recap, we have the user interface, we have the web API that the user interface uses to ask questions, we have the UI that players can use to write code and send code to the arena, and we have the validator to actually validate C# scripts. Finally, we still have one important piece of the puzzle, which is the processor. And you can already guess it, the processor is again a worker service. So it's a worker service that has a worker background service that runs every 2 seconds. And every 2 seconds, it will process something that I called a middleware. So the middleware is actually a little tool that does all the processing, and it splits the processing into multiple steps. And this middleware actually does process, and it gets the arena so that it knows the width and the height of the arena. It gets all of the still living robots, and then it builds a context based on that information. So it builds an object that contains all of that information, and then it will start pre-processing, processing, post-processing, and then updating the whole game state based on those robots. It will update all of those robots. Now, what is processing? What is pre-processing? What is post-processing? Well, basically, pre-processing is compiling all of the C# code that the players have written. So the players write C# code. I need to compile that code using the C# compiler at runtime, so that it can be executed for them. So this is what the pre-processor does. And of course, there is caching involved. When a script doesn't change, it will be cached so that it can be reused and it doesn't need to recompile over and over again. Then we have the processor, and the processor very simply just runs all of those compiled C# scripts. So it will just run all those scripts based on that context. And then the post-processor is actually the most complicated one, because when all of the scripts are compiled and then run, whatever happened needs to be processed. Some robots will walk forward, other robots will do melee attacks or ranged attacks. So I basically need to calculate what happened. So what are the new locations for robots? What are the new orientations for robots? What are the new health and stamina values for all of the robots based on who gets punched in the face or who gets ranged attacked to the face? So very important. And also I work with priorities. If you hit somebody in the face, you have priority of them running away. So basically all of the melee attacks will be executed before all of the walking forwards and stuff like that. So all of that logic is inside of that post processor. And then you can go dig deeper into the actual post processor. You can see it gets all of the ordered bot properties ordered by the fact that they are walking forward or hitting somebody in the face, and then all of the calculations if somebody teleports and stuff like that. So everything right here. And with that, we have all of the different components for this C# wars. Again, I will recap. We have the user interface in the Unity game engine. We have that web API that listens to that Unity user interface for getting the game state every 2 seconds, gets it from the database. We have the web interface for users wanting to play the actual game, which is also connected to the database. Then we have that validator, which is not connected to the database, doesn't really need to. It just gets requests, it validates those requests, and it returns a response, or it crashes because you have made the service unstable. And then we have the processor, which continuously runs, gets everything from the database, compiles all the C# script, runs all the C# script, does all the post-processing, and then updates everything back into the database so that the next time the user interface calls the API, it will get the new version. And with that, this is the end of that introduction into my C# Wars project. And with that, you also saw one of my favorite personal project that I worked on in my free time, because I basically really like to create these kinds of things in .NET, because I really like the .NET programming platform. And so you were able to take a look into 3 of my personal projects that I built throughout the years thanks to the .NET platform. And with that, we reach the end of the final episode of the first season of Johnny Does .NET. Next week, I will start with 30 new episodes for a new season of Johnny Does .NET, where I will talk about C#, the programming language C#. Did you like this video? Don't forget to give me a thumbs up, and if you'd like to be notified of future videos, please subscribe to my channel, and I'll see you next week for a new season of Johnny Does .NET.